Hi there, this is Richard Walker from Lucidate, and today we will be putting LangChain through its paces as we design and build an investment bank equity research application. The role of a sell-side equity analyst involves multiple tasks. We're going to show how LangChain is able to automate and assist in these areas, making the job more productive, and most importantly, allowing the professional analyst to focus on more value-added roles, those that require human judgment and creativity, such as relationship building and networking with clients. Here's an example of the front page of an equity research report from the investment bank JP Morgan. This is covering the company 20th Century Fox, a media company. On this page, you'll see the name of the firm, a recommendation, along with a price target, a stock performance chart, and some pros, justifying the recommendation of the stock. This particular research note is 31 pages long, full of value-added content for JP Morgan's clients. In this video and subsequent videos, we're going to show you how LangChain can chain together business applications, internet search, and large language models to be able to produce a high quality document like this one in minutes, perhaps even seconds, depending on where your information is stored, what LLMs you use, and how fast your internet connection is. Here's a sample front page of a Lucidate built research report on Apple. The code to build this application is in GitHub at the URL on your screen. The URL is also in the description of this video. If you have an OpenAI key, you can download the application now and have it running by the time this video finishes. I hope you will download the app and use it as a base for your own experimentation, as well as being a building block for your own apps. You're free to use and modify Lucidate's code in any way you wish. Consider hitting the super thanks button, which is YouTube's equivalent of a tip jar, if you find the code or this video useful. Both the code and the video are free, but voluntary contributions to show your thanks are always welcome. We can build this app using just a fraction of LangChain's vast capabilities. Here's a review of the LangChain component architecture again. All we need to use to build this app are LangChain's chain components, as well as its models and indexes. In future videos, we'll enhance this equity research application and introduce other components like prompts and agents to build in even more functionality. Let's break down the problem and see how we can solve it. There's some boilerplate information always that we don't need AI for. In fact, we shouldn't use AI for it. Things like the closing price charts, the table of yearly revenue and earnings, and the key financial data are all pieces of information we'd source from a market data provider like Bloomberg or Refinitiv. We don't want our AI hallucinating and making these things up. Now, as most viewers won't have access to things like Bloomberg and Refinitiv, we'll simulate these services with calls to the free Y-Finance for this video. While Y-Finance is not robust enough for professional applications, it's perfectly fine to illustrate how LangChain apps can access real-time data from information services and integrate them with LLMs. Then there are areas where we might want AI to help inform decisions, but the ultimate decision would rest with a professional, human-in-the-loop AI. The stock recommendation is an excellent example of this. Here, the AI can make a proposal for the recommendation, but the ultimate decision would rest with the analyst, or more likely, a committee. And then there are areas where we would love the AI to do most of the heavy lifting. The opportunities for investors text certainly fits that description. What LangChain allows you to do is chain together specialist and generalist large language models, work with tabular numeric information and written text, as well as your own applications to create a library of information on this company. And then, just like a library, ask a series of questions in natural language prompts to be able to get the text that you'd like to put in this section. Now, this is essentially mimicking the task that the analyst would perform in acquiring the source data analysing and synthesising that data, and then writing a report. For this video, we won't build a whole library of information. That would make for a very long video. We'll just use a single document, but it will be a very relevant document. It will be the company's most recent 10K filing. A 10K form is the annual report that publicly traded companies are required to file with the US Securities and Exchange Commission. It provides a comprehensive summary of a company's financial performance and includes details about its operations, financial condition, and management's plans for future growth. You can find company filings at the SEC website as shown on your screen, but we can do a little bit better than that and use the EDGAR module in Python. That will allow us to download any company's 10K with just a few lines of code. Now, once we've done this, we quickly run into a very big problem. These 10K documents can run to 200 pages, contain up to 60,000 words, approximately 100,000 tokens. If we want any currently sized large language model to analyze this, then it would choke. Even the largest general purpose LLMs from firms like OpenAI only accept thousands of tokens at a time as inputs. Enter LangChain, specifically the index components. These components allow us to be able to take large amounts of large documents and split them into chunks that are small enough to be fed into LLMs. They do this in a really efficient way. They don't just chunk up the text, although that is valuable in itself, but they'll vectorize the chunks. That's to say, turn the text into tokens, turn the tokens into an embedding vector, and the series of embedding vectors into an embedding matrix, and store that in a vector database like Pinecone. And it doesn't stop there. When prompted with a question, the index components of LangChain are smart enough to find the most similar chunk of text for the question and load that chunk into the LLM. Useful things, indexes. Let's look at an animated schematic of what's going on with these indexes, and then let's look at the LangChain code to accomplish that. So firstly, we'll have a general question to ask and any particular company to ask it of. We'll create a LangChain function to provide the answer. The first thing this function will do is visit the EDGAR website to get the firm that we've specified's 10K. It then chunks and vectorizes these chunks and stores them in a vector database. With those chunks safely stored and logged, it can then create an instance of GPT 3.5 to do the natural language question answering and summarization. It builds a chain of the vector database and the LLM. It can then pose the question submitted to the function. The chain takes care of the one-shot learning and text creation and produces an answer. Now, here's the LangChain code to do exactly that. This function takes in a company's stock ID and a question. It does the EDGAR magic to get the 10K from the SEC. It instantiates a version of GPT 3.5, splits the doc into 3,000 token chunks with overlap. Now, this is important if the answer to the question spans more than a couple of chunks. It builds a simple chain to set up a summarization of the text, creates the embeddings, stores the embeddings in a vector database, and then uses the chain to get the answer to the question input at the top of the function. Great, now let's see this in action. To make it a little more interesting, let's pose 3 questions to create a reasonable sized opportunities for investors section. Now, in reality, an analyst like Lucy would have dozens or hundreds of questions to pose. The app, if you look at the source code, is written to support that, and I'll do a brief code walkthrough of the Lucidate code at the end of this video after the Lucidate sculpture animation for those who are interested. Here are the 3 questions. You might say there are 5. What are the firm's key products and services? What are the new products and growth opportunities for this firm? What are its unique strengths? Who are the firm's key competitors? What are the principal threats? With that in mind, let's take a look at the app in action. Here's the front page of the research report for Apple. You can see the pro forma stuff that we don't need an LLM for, but are nevertheless vital components of our application. The stock chart, the revenue and earnings table, and the key financials are all down the left-hand side of the document. You can see at the very bottom, the stock is recommended as a buy. But where it gets a little more interesting for our purposes is in the text in the second column. You'll see here that the text is generated in response to our three questions. Firstly, what are this firm's products and services? And it's pulled out iPhones, iPads, Mac computers, and the range of other hardware offered by Apple. The next questions are on growth opportunities and key strengths. Here, it talks about Apple's ability to stimulate a buzz and demand for its products and its solid financial position. Then we conclude with a section on competitors and threats, which seems to focus on force majeure events. Now, the source of all this information, remember, is the chunked up, vectorized text from the latest Apple 10K. This is fed to our GPT model, and LangChain handles all of the coordination to produce our answers. Let's now take a look at Amazon. As expected, this has pulled out both Amazon's retail business as well as the AWS compute suite of services. Growth opportunities are all centered around customer experiences, while strengths revolve around cash management, including collecting from customers before paying suppliers. Threats seem to revolve around financial volatility, destabilizing the cash management of Amazon. Better get some of those fancy derivatives then. As before, this stock is recommended as a buy. And to conclude, we see that Netflix is in the content creation business, with a strength being its ability to dynamically optimize its pricing strategies, with Prime and Disney Plus highlighted as key competitors. In conclusion, LangChain is a powerful tool that can greatly enhance the efficiency of tasks that previously relied heavily on human effort. It can automate and assist in areas such as equity research, helping professionals focus on more strategic and creative aspects of their work. This groundbreaking technology allows us to swiftly analyze vast amounts of data, providing insights and producing high-quality reports in a fraction of the time it would take a human analyst. But it's important to remember that LangChain is not designed to replace humans, but to augment their capabilities, helping them make better informed decisions and ultimately add more value to their work. The ability to involve a human in the loop ensures that while we leverage AI's speed and efficiency, we still maintain the much needed human touch, understanding and discretion in our analysis. As we've seen, the potential application of LangChain are vast, and we've only scratched the surface in this video. We encourage you to download the app, experiment with the code, and explore the endless possibilities that this technology offers. So thank you for watching, and stay tuned until after the Lucidate sculpture if you'd like a brief walkthrough of the app code. And don't forget to like and subscribe for more videos where we will delve deeper into the capabilities of LangChain and continue to revolutionize the way we work. This is Richard Walker from Lucidate. Until next time. Okay, for those still here, here's a very quick walkthrough of the code to give you some pointers as to what's going on. As ever, I always think the best way to learn something is to use it as is and then play around with it, break it, see what happens. So the first section, look, it's essentially loading in the Python modules. I've tried to group them up as well as I can into sensible associations. The first modules handle all of the user interface code. These next modules help us get our source data from the internet, from Edgar and from Yahoo. If you're using different sources, you'll want to replace these import libraries with the ones you're going to use. The next group just handles my OpenAI credentials. I'm going to be using OpenAI models later in the code, but again, if you want to use your own large language model or something you've downloaded from Hugging Face, that will be a great alteration for this code. I definitely encourage you to do that. The next libraries are all of the LangChain modules we'll be using. There are a ton of these, and amongst the many good things that I will say about LangChain, it has great documentation. You will not get lost. So here in the code, I load my OpenAI key, pretty straightforward. And then we have a simple utility function. We're going to get big numbers back from Yahoo, and I want to convert them to millions, billions, and trillions so that we can format them nicely in the table. Here's something for a live app you definitely swap out. This is a dictionary for the stock tickers and the CIK keys to get the data from Yahoo and Edgar, but you'd use a database for this in a live app. But again, this is easy to customize. If you want to add some new firms to this dictionary, knock yourself out. Just put the right names, tickers, and CIK keys, and they'll pop up right in the Streamlit app when you run it. So this is definitely an area that you'll probably want to look at customizing. Now we get into the LangChain stuff. The first piece of code I took straight from the Edgar documentation online. Here we get back the text of the latest 10K, and it's using the dictionary that we defined earlier to get the name and the CIK that you pass into the Edgar company class. We then grab a model. I'm using the default, which at the time of video production is GPT 3.5 DaVinci 003. But if you want to use another LLM, maybe one you've built or downloaded from Hugging Face, here's where you'd put the code in. And again, I definitely encourage you to switch out different LLMs to see what happens. This next bit is embarrassing. This is just a shameful hack, and you can get rid of it if you want. I'm basically doing some chunking of the documents myself, but really simple stuff. I'm splitting it into thirds. That's the reason, or the reason is because, you know, taking a look at these 10Ks, most of the initial text that you get back is all formatting and indexing, and the last third is references. So the stuff you want in the middle of the document. So this is kind of like buying a pastrami sandwich and throwing away the rye bread and keeping the meat. It's pretty messy. You can change it if you want, but I'm trying to save myself a ton of OpenAI fees. Sorry, Sam. Then we formally and properly chunk the data. Bear in mind, you'll need to cater for the prompt and the completion. So I always think it's best to be cautious and err on the lower side of the amount of tokens that you send in. For a demo, you might get away with a smaller overlap than I've got, but overlap is important, as I said in the main video. If your answer is split across several different chunks, adjacent chunks, you want to capture it, and overlap is a great way to be able to do that. So this is the embarrassing bit where I throw away the bread and keep the pastrami. I'm terribly sorry about that. What a hack. We then get the word embeddings and store them in a vector database. I'm using Feist, but here you can switch this out to another vector database like Pinecone. It's entirely up to you. We then build a chain. This is where things really start to happen from a LangChain perspective, from our model and vector embeddings. And LangChain is doing all the hooking up behind the scenes. And this is what makes LangChain so nice to work with. I'm being overly explicit in this part of the code just for demo purposes. We're taking the question that we input into this function seemingly hours ago and then running our chain. Then I'm doing a little bit of formatting of the reply for the return from this function. Now the rest from here on in is just Streamlit code to format the web app. And if you're not familiar with Streamlit, then I'd suggest at least at first you leave it as it is, but maybe you want to tinker around with it later. The first bit is just simple page setup. We create the title and we create a 2-column page. In the left-hand side, we're going to have the chart and the tables and all the financials. In the right-hand side, we're going to have some text. I load the Lucidate logo, change that out, put your own logo in there, I don't care, and set up a drop-down list based on the data in our dictionary that we defined at the top of the script. The next section, it's going to the internet and loading the closing prices from Yahoo into a pandas data frame, sending the data frame to a line chart within Streamlit, and that's a really cool little widget that they've got and displays it in the first column. Again, in anger, you'd be using Refinitiv, you'd be using Bloomberg, but Yahoo works fine. The code then grabs the company description and sticks it in the top right-hand column. The next piece of the code, that builds the revenue and the earnings table. We load the raw data into a pandas data frame and use the utility function we defined at the top of the script to format the numbers. And Streamlit can render a table straight out of the pandas data frame, which is nice. Now, if this wasn't a demo, I'd probably use the same data frame approach for this additional data here, but I wanted to give you some other code you can use for tabular information. So here we're just building a Python dictionary out of the financial data, and then we loop through the dictionary to write the financials in that first column on the left. Now, and this is where things start to happen. Right at the end, we call the function we defined earlier that built and ran our LangChain chain. And I definitely encourage you to add more of these lines with different questions to flesh out the analyst report. And hey, that's it. Please leave any questions in the comments. This is Richard Walker. Until next time.